All right, so today we're going to finish up activity 11 with lesson 11-4, which is going to talk about extending the congruence criteria. So we're going to be applying that to figures on a coordinate plane. And then we're also going to talk about this new HL criteria that we can use to prove triangles congruent. So have this note sheet handy. I am not using the book again, so I'm going to attach the note sheet in Google Classroom with the assignment. So you can use the note sheet to follow along and something to write with, highlighter, vocab sheet. Let's go ahead and get started here. So we have these types of problems where we're given a congruent statement. So we know two triangles are congruent. They want you to find the length of one of those sides when it's drawn in a coordinate plane, like I have in this picture to my right. Okay, so there's two ways I'm going to show you how to do the problem. One way is using the distance formula, which if you remember the distance formula from Unit 1, it is this, where we take the difference in your x values and square it, and add that to the difference in your y values and square it. The other way to do this problem is to use Pythagorean theorem. So a squared plus b squared equal to c squared. Okay, so I'm going to show you both ways, and then you guys can kind of decide which choice you like to do better. Okay, so let's look at this statement they gave us. Triangle DEF is congruent to triangle XYZ. They want us to use this information to find the length of XZ. So really quick, let's look at this. XZ, let's look at our congruent statement. So XZ would have to be then congruent to DF. So that means I have to find the length of this, that length of that side on my triangle. So we're going to use the coordinate plane to do this. So I'm going to grab the ordered pairs from there. So let's look at, so we know that XZ, we're going to use the congruent statement to say that it's congruent to DF. And then we're going to use the picture of DF to actually find the length. Because if I find DF, then I find XZ. Okay, so DF here, my pen keeps going out, so it's being a little problematic today. So D, our point for D, let's see, our ordered pair there is at -4, 1. And our point for F looks like it's at -2, or sorry, +2, -2. Okay, so option 1 is to use the distance formula. So I'm going to go ahead and put this in. So our change in our x's would be 2 minus -4. We're going to square that. Add that to the change in my y's. So -2 minus 1. Square that. And then we take the square root of everything at the end. So let's see. Minus minus is going to turn to plus plus. So this becomes 2 plus 4, which is 6. Here I'll have -2 minus 1, so that's -3. So let's see, when I square these now, 6 squared is 36. -3 squared is +9. So now I'm taking the square root of, looks like 45. Now we can't leave our answer in an unreduced form, so just double check this. Is there any perfect square factors that I can take out of 45? Well, if you remember, 9 and 5 can go into there. 9 is a perfect square, so 5 would be my leftovers. So this would then reduce to the square root of 9 is 3, so 3 root 5. So this would be the length of XZ. So that is one way to do the problem. The other way to do the problem is to use Pythagorean theorem, and we have to be a little creative when we do it this way. So a squared plus b squared is equal to c squared. Okay, so the way we're going to do it is we're actually going to turn this segment that I highlighted green, we're going to turn that into a right triangle by connecting these kind of points. So I'm going to turn that segment into the hypotenuse of a right triangle. Okay. So we're going to actually solve for the hypotenuse. That's always the c value. So to get the a and the b, I just have to count. So the short side here has a distance of 1, 2, 3. And then my long side here has a distance of 1, 2, 3, 4, 5, 6. So those are my two legs, and we're going to solve for the hypotenuse. So the a, if the a is 3, That means we're going to have 3 squared plus my b, which is my longer side, which was 6 squared. That is to be equal to my hypotenuse, which is the c value, c squared. Okay, so if I do that, 3 squared is 9 plus 6 squared is 36 equal to c squared. So again, I'm going to get 45 is equal to c squared. So then the last thing to do to get the c by itself would just be to square root each side. So we're going to get the same answer. So our hypotenuse there would be the square root of 45, which we already reduced to 3 root 5. So that's 2 ways to do the problem. So using the distance formula by grabbing your ordered pairs, okay, and plugging them in, reduce your answer if you can. The second way to do it, if you prefer, is to use Pythagorean theorem. So turn the side of your triangle into the hypotenuse and kind of connect the sides to form a right triangle and use a squared plus c squared and solve for the hypotenuse, the c. Okay, so I'm going to have you guys try this one here, example 2. So it says that triangle ABC is congruent to triangle DEF. Okay, so they drew ABC in your coordinate plane there. So you're going to use that to find the length of EF. So go ahead and do that. Take a second here. Use whatever method you like, distance formula or Pythagorean theorem. You don't have to do both. Just pick whichever one you like better. Okay. If you got it right, you should have got that EF is going to be the square root of 29. Okay, so here is my work there. So in black, I'm using the distance formula method. And in green, I'm using the Pythagorean theorem method. Okay. So if you need to pause to kind of check out that work, then do it. Let's just finish up this note sheet then. On the next couple problems, we're going to determine the third piece of information we need in order to prove congruence by one of our postulates. Okay. And remember, vertical angles and reflexive sides are assumed, so you can mark those in your picture. But if I want to prove that triangle ABD is congruent to triangle CBD by side angle side, what extra piece of information do I need to know there? Okay, hopefully you said that we need to know that AB is congruent to CB. Because remember that reflexive property means that I can assume that BD is congruent to itself. So in order to use side angle side, I would have to know that these sides are also congruent. Because remember, the angle would have to be in between our congruent sides. All right, try one more here. B, if I want to prove triangle JKN is congruent to triangle MKL by angle angle side, what piece of information is missing in our picture? Well, we would have to know that angle L is congruent to angle L. Because remember, vertical angles we can assume already. So in order to get angle angle side, I would have to know that this angle is congruent to this angle. And then I can prove it. Remember, angle angle side, it has to go in that order. Okay? All right, flip your note sheet to the back page, and we're going to talk about one more criteria, which is called the hypotenuse leg criteria that we can use. So in order to prove triangles are congruent by using the HL criteria, we need these 3 things to be true. Okay? The first thing that we need to know is that we have 2 right angles. That means we have to have a right angle in the problem. So they should tell you either it's 90 degrees, something about being perpendicular, or in fact, they say right angle. The other one is the hypotenuse. So the hypotenuse is always the side across from your right angle, diagonal from the right angle. The hypotenuses have to be congruent as well. And then you just need 1 pair of legs to be congruent. So it doesn't matter which leg you have, as long as you have 2 legs that are congruent, you can use HL. So you're going to need right angles, congruent hypotenuse, and 1 other leg congruent from your triangle. Okay? So let's answer a couple questions. So in number 4, I have a picture here of 2 triangles side by side. Is it possible to prove that triangle LKM is congruent to triangle JKM using the HL criteria? If not, what are we missing? So can I prove these triangles using that HL? Yes or no? Okay. So remember, we can assume by the reflexive property that we have congruent here. Km is congruent to itself. So we have the hypotenuse, it looks like, in one leg, but I'm missing the fact that we don't have right angles. In order to use HL, I would have to know something about the angles being a right angle, and that has to be given to us. We can't assume that. Okay, so if those were right angles, then we have a hypotenuse and a leg. We can use HL, but because they did not say anything about right angles, I can't use it. Okay, and it's not depicted in my picture using a little square. So just make sure you have all the pieces you need for that. So let's look here. For each pair of triangles, write the congruence criteria, if any, that can be used to show that the triangles are congruent. So in number 5A, can I prove that these two triangles are congruent? And if so, what criteria am I using to prove it? Okay, so actually, yes, we can prove congruence because we can use reflexive property here. So if you notice now, we have a right angle. We have the hypotenuse because it's the length that's across from the 90-degree angle. And we also have one leg that's congruent. So this is the HL. Okay. So even though this looks kind of like side angle, which I said we can never use, we can use it if we have right angles in our problem, because the right angles let us use that criteria of HL. Okay. So look out for those. If those were not right angles, then we could not prove these congruent. All right, what about B? Can we prove that B are congruent triangles? We have right angles. Does that mean I can prove using HL? So take a second and look at the picture, mark what's assumed, and see if we have enough to prove congruence. Okay, actually, we can't prove anything here. Although we do have that reflexive side that's shared, in order to prove congruence, I would have to know that my hypotenuses are also congruent if I'm going to use HL. Or I would have to know maybe another side is congruent or another angle to use any of our side, or angle, side, angle, anything like that. Okay. So just make sure you know what you're given, mark what's assumed, and do you have enough? Remember, we always need to have 3 things to prove congruence. So let's just finish this off with a proof. So we're going to write a 2-column proof for this statement here. So it says triangle ACB is a right angle. So ACB. So I'm going to mark that in my picture. And triangle ADB is a right angle as well. So let's mark that. They said that AC is congruent to AD. AC and AD. We're going to prove that these two triangles are congruent. Okay, so let's start with our given statements. So we know that angle ACB and angle ADB are right angles. And we also know that AC is congruent to AD. So our reason there, that is given. Now, is there any assumed properties that we have here? So remember, if it's assumed, mark it in your picture. So I can say there that AB is congruent to itself by the reflexive property. Okay, so right now we have an angles, a right angle. We have one side and another side. So it looks like I have 3 things here, so I can prove congruence. I can say that triangle ADB is congruent to triangle ACB. So look at what we have. We have a right angle. We have an hypotenuse congruent because that's what AB is. It's our hypotenuse for each right angle. And we have one leg. So this is an example where HL can be our congruence criteria here. But again, you could only use HL if you have right angles. So if you're noticing your problem has right angles, you're probably going to use HL. But that don't forget to leave out, we still have all of our other criterias, the SSS, the ASA, the SAS, and the AAS too. I'm just gonna fix this up a little bit. It's a little sloppy. My pen broke a little bit in the middle. There you go. Okay. So again, make sure you look at your assumed things like reflexive property, vertical angles. Mark your picture, because once your picture is marked, you can kind of decide what direction your proof is going to go. Okay. So that is the end of activity 11. So we're going to start prepping now for our comprehension check.